If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM. You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Good evening, everybody. Welcome to York Universe, the astronomy and astrophysics program written and presented by the students. Oh, yes, they're terrific. Faculty, alumni, not to mention the darn good friends of York University. I'll be one of your three hosts this evening. My name is Paul Delaney. I am joined by Miss Observer herself. Hi, Sana.
Hi.
Hi. And we've got Palvisha on the line tonight.
Hello.
Hello. Glad to have you here. We are broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. And of course, it is Monday night, therefore it is Astronomy Night in Canada, where the lineup is entirely Canadian, starting with ourselves, York Universe, on to Western World's Quirks and Quarks, as well as Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time. That's Eastern Standard Time at the moment, which of course is Tuesday morning, 2 a.m. Universal Coordinated Time. The York Universe production works in concert with our online public viewing program run by the Observatory team. Hi there, team. It runs, of course, between the hours of 9 and 10 p.m. Coincides with us here, local Toronto time. By all means, go over to observatory.info.yorku.ca and follow the links to OPV, online public viewing, or head across to YouTube and do a quickie search for the York University Observatory or the Allan Carswell Observatory. That'll bring you to our YouTube channel. Our broadcast is powered by and is in partnership with Astronomy.fm, the voice of astronomy. If you've got any questions or comments about past shows or suggestions for future topics, by all means, send us an email, observe@yorku.ca. You can always connect with us on Twitter or Instagram with the handle @York Observatory and on Facebook at Allan I. Carswell OBS. All of our programs are free, but if you would like to make a donation, visit our website, observatory.info.yorku.ca, and look for the big button, big friendly button. We will be monitoring the chat room for questions and trying to post content over there on the YouTube channel. The weather at the moment is terrible outside. Okay, we had snow yesterday, and it's trying to snow again, minus a couple of degrees Celsius. Yeah, the observatory team is completely at home and online, showing you wonderful archival images. No live images from the 1 meter telescope tonight. Well, indeed. So, Sana, Palvisha, seeing I've spoken to Sana recently, Palvisha, what are you up to on these snowy November days?
Just trying to get through school and work, and that's about it. Nothing special.
Well, that's two full-time occupations, absolutely. Did you get up for the eclipse the other day?
No, I wasn't able to. I planned on watching it, but I fell asleep.
Okay. Well, I guess it does tend to play havoc if you've got to get up and go to work the next morning.
It does.
It does. Done any observing or photography recently?
I have a bunch of images that I have to still go through and reduce. So I haven't taken any new ones, but I'm hoping to get to them during the Christmas breaks, like the winter breaks.
One of your 3,000 things to do between Christmas and New Year?
Yep.
Yep. What about you, Sana? Have you done any observing this past week?
No. The last time was the eclipse.
Right, yes. Well, you took, what was it, about 1,000 photographs that night?
About 1,000, yeah.
Yeah. Quite amazing. So hopefully you'll get a few of those processed as well, and I know that June is going to be doing a bit of processing.
Yeah, I don't have the time to do any of that right now, so just like Palvisha, I'm going to be doing that over the winter break.
The lives of students, I remember. Yep. I know, I do sympathize. I can't apologize, but I will sympathize for you. Okay, all right. Well, let's get on the road then with This Week in Space and Astronomy History. Tell you what, just while you guys get yourselves together, I will take the first item. November 27th, 1885. That was when the first photograph of a meteor shower was taken. Now, photography by 1885, I won't say it was mature, but certainly it had come into its own. Glass plates existed, the modern technique using sort of, photosensitive materials, which didn't kill you, so as to speak, in contrast to some of the techniques in the 50s and the 60s, the 1850s and 60s, that is. But photography was mature. We'd photographed the Orion Nebula, the moon regularly, and so on. But up until 1885, we had not successfully imaged a meteor shower. Well, the image in question, November 27th, 1885, was taken by an Austrian-Hungarian astronomer, Ladislav Weinek, from an observatory in Prague. And he went after it very deliberately, which was really good. It was the Andromeda meteor shower, and just for a quick reminder, that's associated with Comet Biela, which broke up in the early 1840s. Bit of controversy about whether or not it was 1843, 44, 45. Let's just go with the early 1840s. But, of course, like most modern meteor showers, but not all, but most of them are, of course, the remnants of a comet which has broken up. One too many times past the sun, gravitational stressing eventually shattering the cometary nucleus and leaving a nice rubble train in its orbit around the sun, the comet's original orbit around the sun. But we know that now. That wasn't always known. And in fact, what the heck meteors were back in the pre-19th century era was up for huge debate. In fact, for the longest time, there was a belief that they were associated with literally terrestrial phenomena of some description. But starting at the beginning of the 19th century, more and more people were beginning to point to the possibility that the meteor showers and meteors themselves were of an extraterrestrial nature. Sounds a big deal. It was a big deal back then. As I say, we take it for granted now. But back in 1834, there was a rather clinical summary done by an astronomer by the name of Olfsted, who was lucky enough to see the Leonid meteor storm of 1833. This was a phenomenal display of meteors that literally streamed into the Earth's atmosphere at the rate of thousands per hour. It truly lived up to its name of a storm, and it actually caused a great deal of panic on the ground. As you can well imagine, shooting stars at that level of frequency and the brightness associated with them was a bit of a terrifying sight by all accounts. Well, of course, astronomers reveled in it, and they collected a lot of data associated with the shower, and it was Olmsted that actually put forward a fairly compelling argument that suggested that meteors were of an extraterrestrial nature. It wasn't, though, until later in that century by Schiaparelli, yes, of Mars Canale fame, 1867, he actually correlated the fact that meteors, or more to the point, meteorites, were of an extraterrestrial nature and were associated with comets and cometary orbits. At any rate, enough of the history lesson with respect to meteors and meteorites. The important point here is that the first image captured, and it just showed one streak across the photographic emulsion, but the first successful photographic evidence, shall we say, of a meteor was taken November 27th, 1885. Austrian-Hungarian astronomer Ladislav Weinek. Hard to believe that meteors and meteor showers and so on were an unknown. The origins of such showers was an unknown phenomena, more or less as recently as sort of 1834. That's less than 200 years ago.
Yeah, I can't imagine how scary it would have been during some meteor showers or that meteor storm when you don't know what's going on.
Mm-hmm. Absolutely. And of course, the skies were very dark and very pristine back in 1833. So even the fainter meteors that were streaking through the atmosphere put on quite the show. I've seen images. There was no photographic evidence, but there were people who have drawn sort of imagery of that particular night. And literally, it's stunning what they drew. To be witnessing that type of event would be I think would be fabulous, but back then was absolutely mortifying. That was scared silly.
Yeah.
But meteor showers are one of those wonderful phenomena that you can go out and observe. And you don't need a telescope. You don't need a 1 meter telescope. You just need a comfortable chair and a dark sky. And you can sit back and, it's a celestial fireworks display. I never tire of them, although you've got to be patient because, of course, you never quite know when the next meteor, shooting star, is going to come across the sky.
Yeah, they're definitely a lot of fun to watch, especially when you're with some friends. Just
Yes.
hang out and have fun and just watch a meteor shower.
It's one of the reasons that the Perseids in August are so popular, because you can sort of hang out and not freeze to death. Problem here in Canada, watching the Leonids. Can't remember whether or not either of you were on top of the Arboretum with us a couple of years ago when we did the Orionid meteor party.
Oh, we were there.
Yep.
Yeah,
Okay.
I remember doing one meteor shower on the Arboretum. I think it was probably the Orionids.
I think it was. It was like that one night where we saw a bunch of meteors go by along with some satellites.
Yes, yeah, we saw a few, which was good. But again, you had to be in the right place at the right time. And I remember the crowd that was up there. Somebody would say, "Oh, there it was," and everybody turned in that direction. And of course, it's too late by that point. So, I dare say there were some folks who just didn't see anything because they weren't captivated by the night sky.
With the Perseids, in August, I was out pretty late at night and actually saw a very bright streak go by.
Very good, but a bolide.
Yeah.
If it's up around sort of magnitude 0 or thereabouts, that's up into bolide territory, which of course is very nice.
Yep, I got to see that. It was really nice. I wasn't expecting it at all.
Yeah, well, that's the best when you're not expecting it and then you do see it. It's very good, very good. Well, speaking of streaks across the sky, Sana, a launch of STS-88?
Yes. So the STS-88 was a shuttle mission. It launched on the night of December 4th, 1998. And speaking of looking at amazing things in the sky, I just love these night launches. They're always spectacular. It launched from Pad 39A at the Kennedy Space Center on the Space Shuttle Endeavour. It consisted of a crew of 6 people. There were 5 NASA astronauts, Commander Robert Cabana, pilot Frederick Struckrow, mission specialists Jerry Ross, Nancy Curie, and James Newman. And then there was one cosmonaut, Sergei Kirkolev, who was also a mission specialist. This is a pretty significant shuttle mission because it was the first space shuttle mission to the International Space Station. And because it was so early in the history of the ISS, the main mission objectives for STS-88 were basically to connect the US-built Unity Node 1 module to the ISS. At the time, the ISS actually only consisted of one module, which was the Zarya module, and that had been built by the Russian Space Agency and really only launched a couple weeks earlier on November 20th, 1998. So this was really the very, very early days of the ISS, and they needed to go up there and essentially build a part of the space station. So a day after their launch on December 5th, the crew removed the Unity module from the payload bay and placed it above the orbiter docking system, which would mate Unity to Zarya. Then the next day on December 6th, astronauts Robert Cabana and Nancy Curie guided the 2 modules together and physically mated the 2. Following that, astronauts Jerry Ross and James Newman had to complete 3 spacewalks. The main goals, or the main things that they needed to do on these spacewalks were to just finish connecting the modules and also prepare the outside of the space station for future astronauts. The first spacewalk they did was on December 7th, and then the second was on December 9th. And mainly what they did on those 2 were connect Unity to Zarya's electrical systems, which is where Unity was going to be getting its power from since Zarya had solar panels on it. They also installed communications antennas on Unity to establish ground communication and fixed a jammed antenna on Zarya. After their second spacewalk on December 10th, with Endeavour docked to Unity, Robert Cabana and Sergei Kirkolev both opened the hatch to Unity from Endeavour and went into Unity, becoming the first people to enter the International Space Station. The rest of the crew eventually did follow them, and then they later also opened the hatch to the Zarya module, becoming the first people to enter the Zarya module as well. The crew stayed on board there for about a day, just doing some general things to get the space station going. They were unstowing some hardware and activating Unity. And then after that, they returned to Endeavour. It would kind of suck to have to stay in just Endeavour when you have the whole space station, but apparently they stayed in Endeavour for the rest of the mission for a few days. The final spacewalk that they needed to do took place on December 12th, where Ross and Newman installed tool bags on the outside of the space station for future crews to use. They also installed some handrails, tested those emergency jetpacks in case somebody were to come untethered from the space station, and repaired a couple of exposure experiments that were on Zarya. Finally, the crew undocked from the ISS on December 13th, where they flew around the station to take some pictures of it to document what they had done. And then they also deployed 2 small satellites. And with that, they completed all of their mission objectives. So it was a really, really successful mission. And then landed at night again at the Kennedy Space Center on December 15th.
Hard to believe that it's barely 20 years since the ISS became fully operational, and here we are, chronicling the activity, shall we say, of building the station. So 1998 to now is 23 years or thereabouts. It seems like forever, yet it seems like yesterday at the same time to me.
Yeah, it's kind of crazy when I think about it. Like, there are people like me who their entire lives there have been some people who haven't been on the Earth. There's been continuous occupation of the space station. It wasn't since 1998. I think it was maybe a couple years, maybe 1 or 2 years later.
2000, November of 2000.
Okay, so I was born June 1999, so I don't quite make the cut. But there are some people who just like the space station has always been occupied their entire lives. It's a little crazy to think about.
It's close enough for you, Sana, and I dare say it's pretty well the same situation for Palvisha too.
Yep, February 1999.
I wasn't probing, but I was guessing. But yes, there's been somebody in Earth orbit for the vast majority of your respective lives, and that's something I cannot say. I was born before anybody had figured out how to get a rocket into orbit. That just dates me, of course. But now, anybody who is born, including my grandson, Earth orbit is going to be in continuous occupation, at least I hope. And, of course, soon we'll be able to say, people will be born in a situation where there has been somebody on the moon continuously. That, hopefully, is only about 5 years away. But we'll see. At any rate, the space shuttle did an excellent job. I mean, we could debate the usefulness of the shuttle as a tool for space exploration, but there is no doubt that the ISS would never have come into existence without the ability, the versatility of the space shuttle, the Canadarms, and of course the ingenuity of the crews who went up and assembled the space station over the better part of sort of 3 or 4 over the better part of a decade. Good stuff. Palvisha, I believe you have a story about near misses, so as to speak.
Yep, I'm taking us back to our discussion about meteorites. So this week on November 30th, 1954, Anne Elizabeth Hodges became the only human confirmed to be injured due to direct impact by meteorite. So the story behind this is that then 34-year-old Anne Hodges was taking a nap in her Alabama home when a fragment of a meteorite came barreling through her roof at around 2:46 p.m. that day, hitting her on her left side. She's the only confirmed direct injury. The meteorite that had hit her is known as the Sylacauga meteorite, but more commonly dubbed as the Hodges meteorite, named after her. The fragment that hit her weighed approximately 3.86 kilograms, which is around 8.5 pounds, and had originated from a meteor that was moving at around 200 kilometers per hour that had split in half. The fragment that came in through her roof bounced off of her radio console and onto her, leaving a large bruise, and the other fragment landed a few miles away from her home. According to the late Michael Reynolds, who was a professor of astronomy at Florida State College, Jacksonville, his comment about this incident was that you have a greater chance of getting hit by a tornado, lightning bolt, and hurricane all at once than you do by a meteorite. So I guess talk about getting unlucky. Anne Hodges had a dispute with her landlord over ownership of this meteorite, but was eventually able to keep the meteorite after paying her landlord $500. After an unsuccessful attempt to sell the meteorite, it was eventually used as a doorstop before being donated to the Alabama Museum of Natural History. The fine print with this specific incident is that the Anne Hodges incident was the first confirmed case of a person being injured directly by a meteorite. However, there have been other reports of meteorites hitting people, but have been controversial and couldn't be confirmed. An example is the 2016 incident where it was reported that a bus driver in Natrampally, India, suffered fatal injuries after being struck by debris ejected when a meteorite hit the ground, but this couldn't be confirmed. Another incident which occurred very recently and didn't result in any injuries was this year in October, where Ruth Hamilton, a Golden, British Columbia resident, was narrowly missed by a meteorite which landed in her bed just inches away where she was laying. It didn't hurt her, so she was perfectly fine. Although it was a confirmed incident of a meteorite landing in someone's home, it didn't injure her, so it's not a confirmed case of anyone being injured by a direct meteorite impact. Aside from this, there is one other confirmed fatality of someone being hit by a meteorite, but the someone isn't a human. It's a cow that was hit by a meteorite in Venezuela in 1972, and it had died as a result. So with all of that being said, the chance of space rock crashing through your roof is pretty low, but never zero.
You're absolutely right. I mean, it's a very, very low probability. You definitely have a better chance of winning the lottery. But as you have just indicated, given enough people and given enough time, the possibility of recording a meteorite impact on your home is decidedly not zero. I mean, you've cited two cases here, and I'm fairly sure I remember an incident in New York City where somebody's car it wasn't totaled, but the meteorite did strike the car, it took out the tail light and so on. So it can happen. I mean, there are literally thousands of meteorites that land on our planet on a daily basis. Most of them, of course, are in the ocean. Many of the rest end up in fields and you can't find them. And that's one of the reasons why we go down to Antarctica every summer to try and find meteorites, because, of course, there isn't much action down there. Farmers are not plowing meteorites into the field. The meteorites strike the ice. They don't bury in the ground. When the ice melts, the meteorites are literally sitting on top of the ground waiting for people to pick them up. So these are wonderful little time capsules. But, if one comes through your roof, it could be a little harrowing.
Absolutely. I feel kind of bad for the cow as well. Sure.
I hadn't heard about the cow. Yep, it does happen. Well, I mean, we lost a sort of a cow and a kangaroo when Skylab came through Western Australia in 1979. I mean, that's a little unlikely too. Space debris, so as to speak, killing something. But yeah, it does show that low probabilities doesn't mean zero. And, of course, if you do end up finding a meteorite, take it to your nearest museum. I don't quite know why Hodges wasn't able to sell it to a museum, because today most museums will happily haggle a price and buy a meteorite from you.
Yeah, the other half, I forget who found the other half, but they were able to sell it off perfectly fine and, in fact, be able to afford a new car and home with the money that they received.
Oh, man.
Well, that sounds a little more like it. It really does. Ah, dear, poor Hodges. Oh, dear. Okay, let me take you up into space over to the Hubble Space Telescope. No, Sana, it's not the Webb telescope yet. It's just the Hubble. And a detection of sodium by the HST on November 27th, 2001. The planet in question is named Osiris. Okay, Osiris isn't the real name of the planet. It's got the wonderful number HD 209458. If you don't know Osiris, it is a hot Jupiter and was discovered by the transit technique back in September of 1999. Now, why is this so important? Well, it is the first planet that was investigated spectroscopically because of its detected planetary atmosphere. Yes, a planet with an atmosphere. Of course, we know lots of planets have atmospheres now, but back then, back in 2001, that was not the case. 209458b is a planet about 3.5 times larger than Jupiter. That's its diameter, but it's only about 71% of the mass. So it's a hot, fluffy Jupiter, and it has an orbital period of about 3.5 days. Well, if you think about it, Mercury has an orbital period of 59 days. The parent star is a solar analog. So this tells you that Osiris is orbiting perilously close to the sun, hence, or its star, parent star, hence why we refer to this as a hot Jupiter. When they are that close, of course, the atmosphere and the planet itself are being pummeled by the intense radiation from the parent star. It's in the constellation of Pegasus, by the way. It's about 159 light years away. The initial spectroscopic analysis by Hubble revealed in the atmosphere, amongst other things, hydrogen, carbon, oxygen, water vapor, and, yes, sodium. This was the first planetary atmosphere that had this combination of gases, and, of course, everybody was a touch surprised to find sodium there. It also has a magnetic field. It's about 10% the strength of Jupiter. Hot and fluffy because when it is that close to the parent star, the atmosphere swells up to enormous size. So, yes, it's much larger in diameter than Jupiter, but most of that is a result of the expansion of the atmosphere because of the intense heating. We're talking about a couple of thousand degrees Celsius in the atmosphere. So this is decidedly inhospitable. Not surprisingly, the planetary atmosphere is also evaporating. With those sorts of temperatures, with the hydrogen gas, which is very common in Jovian planets, even with this relatively strong gravitational field of the planet Osiris itself, it's not enough to retain all of the hydrogen being that close to the sun. So literally, this planet is shredding its atmosphere, or the star is shredding the atmosphere of the planet, and there is a long hydrogen tail that is spreading out behind this particular planet. Obviously, the planet's days are numbered as far as the atmosphere is concerned. The rock itself will be retained for long periods of time, but the atmosphere itself, it's not going to last for particularly long. We're talking about probably only tens of millions of years. At any rate, this date, November 27th, 2001, planet Osiris, courtesy of the Hubble Space Telescope, the detection of sodium in the planetary atmosphere. I wonder if it'll be a prime target for the James Webb Telescope.
I can look that up, actually. It might take me a minute, but I can look it up. I've learned how to search the Cycle 1 proposals.
And for those folks who are wondering, yes, Sana's master's degree is sort of a little bit dependent upon, hopefully, the James Webb Telescope launching. We'll talk a little bit about that later on. I think Palvisha is going to give us an update on when we can expect this famed telescope to launch. But, atmospheres around planets, of course, when you look across our solar system, most of the planets in our solar system, really the only exception is Mercury. All other planets have reasonable atmospheres to substantial atmospheres, particularly the Jovian worlds. So it should come as no surprise that as we found more and more exoplanets, the detection of planetary atmospheres became very, very important. And Hubble, of course, has been one of the key instruments in doing those planetary atmosphere detections.
Yeah, I was listening to something about James Webb, and they were talking about some of the exoplanets that it's going to observe. I can't find this one on the Cycle 1 observations, but I might just not be looking in the right place. But I heard about this really cool planet they're wanting to observe. It's like a lava planet where
Okay.
it basically, yeah, it's like Earth, and it has its own atmosphere, but the atmosphere can have clouds of rock.
Clouds of rock. Okay.
Yeah.
We're
It
going to
sounds
find a lot of interesting planetary atmospheres, I'm sure, or planetary environments, excuse me. I mean,
Yeah.
we're up to over 7,000 exoplanets these days, and some of them truly have unusual characteristics. So I'm sure Webb is going to have a lot of fun working their way through the exoplanetary catalogs.
Mhm. That
Very,
planet sounds crazy.
very good indeed. Okay, well, speaking of other planets in our solar system, shall we talk a little about Mars? No?
Yep,
Oh,
I've got.
Done it?
oh, sorry. I was
Still with
muted.
us?
Didn't realize that. Oops. Sorry.
Oh, you're up.
Yeah, so it's November 26th, 2011, which was the launch of the Mars Science Laboratory. Perseverance and Ingenuity being the most recent probes to go to Mars have kind of been dominating a lot of the news when it comes to Mars. But there are a lot of other things that are on Mars, including the Curiosity rover. And last Friday on November 26th marks the 10th year or the 10th anniversary of the launch of Mars Science Laboratory, which was what brought the Curiosity rover to its home in Gale Crater. Curiosity at the time that it was launched was very, very different from other rovers that had been sent to Mars. In particular, it was supposed to be just totally different from the twin rovers Spirit and Opportunity. Not only would Curiosity be significantly larger and carry a lot more of a scientific payload than Spirit and Opportunity, but it also wouldn't be using solar power like those rovers. What it actually used instead of that was this radioisotope thermoelectric generator, or RTG, which uses the decay heat of plutonium-238 to generate electricity. The plutonium-238 on Curiosity is a 4.8 kilogram chunk, and it's just been running off of that instead of using solar power like a lot of the Mars rovers do. After it launched, it had an 8-month journey to Mars, after which the Mars Science Laboratory executed a very, very accurate landing. It dropped Curiosity off only 2.5 kilometers from the center of its landing ellipse, which was the most accurate of any of the Martian landings at the time. It put it in Gale Crater, which is a little bit north of Mount Sharp, which it began to scale when it started moving. So some of the main scientific goals from the Curiosity mission were just to study the Martian climate and geology, and also to determine the habitability of its landing site and if water could play any role in that, if Mars is habitable. Curiosity accomplished so many things during its nearly 10 years on Mars.
Let's not use the past tense. It's continuing. It's not dead and buried.
It's still there.
Yes.
But yeah, even now it's accomplished so many things that we can't even begin to go into any detail on the things that it's accomplished now. It would just take way too much time. But one interesting thing is that it has been operating now for 3,300 sols. With a sol being one Martian day. But that still doesn't make it the longest lived Martian rover. That honor remains with the rover Opportunity, which I believe is no longer operating.
That's correct.
It was had its solar panels covered by dust during one of the storms a couple of years ago, I think.
2018. Yep.
Yeah. Opportunity operated for just over 14 years for 5,110 sols, but it is generally expected that Curiosity will eventually break that record and outlive Opportunity. This is because the RTG that it has was designed to deliver enough power to operate the rover for at least 14 years. So just as long as Opportunity's mission. But a lot of NASA's RTGs generally outperform their design specifications, so it is also possible that Curiosity could operate until the 2030s or even the 2040s, given no unexpected hardware or software malfunctions. And I really hope it does, because losing those rovers is always kind of sad.
It's very true. When we lost Spirit, and then when we lost Opportunity, OPI, as it was, often referred to, it was very sad. There were poignant moments when both the rovers sort of stopped transmission. You become very attached to these sorts of vehicles. In the case of Opportunity, as you said, Sana, 14 years, but it was about 10 years in the making. So there are some people who literally spent 25 years of their life working, living, and breathing the activities associated with Opportunity. So when you're doing that length of time with something, you become very attached to it, even though it was a robot.
Yeah. I think it doesn't help that NASA, at least now, does things like make Twitter accounts for the rovers and they write tweets from the rover's perspective.
Yes, that's exactly right. They really do make them, people oriented, that's for sure. But Curiosity has done very, very well. Our own Dr. John at York has spent a lot of time with the Curiosity rover, as has his grad student team, examining the Martian atmosphere, the cloud cover, and so on, contributing significantly to the methane debate. So we've heard a lot about Curiosity over the last 10 years at York, which I, for one, think is pretty darn good. Absolutely. And, of course, we shouldn't forget that there is another rover on Mars other than Perseverance, and that is the Chinese Space Federation's rover. It landed in May and, by all accounts, is continuing to operate very happily as well. So there are 3 operational rovers on the surface of Mars at this point in time. Palvisha, you want to take us to Mars as well, I believe.
Yep, all the way back into 1971. So this week on December 2nd, 1971, the Mars 3 lander landed on Mars. Mars 3 was an unmanned spacecraft that was a part of the Soviets' Mars missions that took place between 1960 to 1973. This specific mission had ended the Soviet streak of a decade-long streak of failed missions. It made a successful soft landing just 5 days after the Mars 2 spacecraft had crash landed onto Mars, and became the first spacecraft to fulfill a soft landing on Mars. It transmitted back radio signals and a fuzzy image before it cut out and died. But that was the first ever image that was taken on Mars's surface, which was lost along with it, but then retrieved again in the 1980s. The malfunction that had killed the lander occurred during one of the fiercest Martian storms known at that time. So it suffered the same fate as Opportunity, unfortunately. After the images were retrieved in the 1980s, NASA crowdfunded a hunt for Mars 3's debris. They had taken images with the reconnaissance orbiter and had opened the images to the public for them to look for debris in their images that was left over from Mars 3. The debris was eventually found by Vitaly Agorov and other Russian amateurs in 2013. That image that was taken by the Mars 3 lander was captured on December 2nd, 1971 by its TV camera, but the image, due to it being incredibly fuzzy, was there was speculation regarding it, whether it was actually noise or if it was an actual image of the Martian dust storm. The Soviets at that time had concluded that the image was useless and didn't share it with the public until the late 1980s. When Soviet leader Mikhail Gorbachev encouraged collaboration with the West. Despite the Soviet conclusion that the image taken by the lander's TV camera was useless, there are some that still believe that the lander did in fact succeed to image the Martian dust storm.
The image, of course, is readily available on the internet these days. You certainly can't see anything of significance there. The probe only was transmitting for about 15 seconds or thereabouts, so it wasn't a terribly successful mission, other than it did make it to the surface, and so credit where credit is due. But regardless of whether or not you think the image is or is not of the dust storm, it isn't particularly useful, but it was the first transmitted signal from the surface of Mars, regardless of whether or not you like the image or not. It was a transmission, and it was a deliberate transmission from Mars 3. The Mariner 9 spacecraft had arrived in orbit just about a month prior to the Mars 2, Mars 3, because, of course, we can only send to Mars every 26 months, and so NASA had sent Mariners 8 and 9, although Mariner 8 ended up at the bottom of the Atlantic Ocean. Mariner 9 did succeed in going into orbit, whereas Mars 2 and 3 were straight in trajectories, and despite the fact that there was this fierce dust storm, they could not stop the spacecraft from going down, which is unfortunate, because if they had managed to put them into orbit and then deorbited them at a safer time, it might have been a very different history as far as Mars 2 and Mars 3 is concerned.
Yeah, it wouldn't have ended up dying out the same way Opportunity did.
No, that's exactly right. Now, Mars is very unforgiving. As often is said on the SpaceX broadcasts, there's 1,000 ways the mission can go wrong and only one way for it to go right. And that really sums it up very, very well whenever you're going to the planets. Mars was particularly difficult. Up until the early 2000s, we had lost more spacecraft trying to go to Mars than we had successfully put into either orbit or land on the surface. That situation has improved steadily throughout the 21st century. Most of the missions since 2000 by NASA, China, the United Arab Emirates, the European Space Agency have been successful. Not all, but most have been successful. So now more vehicles have been successful going to Mars than not. So definite step in the right direction. Do either of you remember the last failed mission to Mars?
I don't.
I don't. Was it an Indian mission? I'm not completely
No,
sure.
the Indian Space Agency was successful in getting MOM to go into orbit. No, it was a Russian-built lander that was on the European Trace Gas Orbiter mission. It was a little lander by the name of Schiaparelli, which unfortunately ended up creating a new crater on Mars rather than soft landing. That was in 2016. Piece of trivia for you. Folks, you're listening to York Universe, the weekly broadcast of astronomy and astrophysics out of the Allan Carswell Observatory, York University, Toronto, Ontario, Canada. Myself, Paul Palvisha Sana, keeping you company tonight with This Week in Space and Astronomy History. By all means, point your favorite web browser to observatory.info.yorku.ca. Join the OPV, the online public viewing team, with some wonderful archival images and scintillating conversation. No live broadcast, though, from the 1 meter telescope. Very cloudy here in southern Ontario tonight. A reminder that this coming Wednesday, of course, is our Teletube event. So it's Telescope YouTube, where the observatory team will regale you with interesting facts on a particular topic. And, of course, if the weather permits, live imagery from the 1 meter telescope. That is 7:30 to 8:30 on our YouTube channel this coming Wednesday. Sana, you've got a little note here, I believe.
Yes, if you are interested in watching spacewalks, which are always really fun to watch, there is one coming up tomorrow at 7:10 a.m. It's U.S. spacewalk number 78 involving astronauts Tom Marshburn and Kayla Barron. They're also going to be two of the other crew, I think, is it crew 3 now? Crew 3 astronauts who are going to be using the Canadarm to help them out on the spacewalk. They're going to be replacing some communications system for S-band communications. The broadcast starts on NASA TV a couple hours before the spacewalk starts at 5:30 a.m., and the spacewalk will last about 6.5 hours. So if you're interested in watching them, they can be pretty fun. Tomorrow morning there's one tomorrow.
Make sure you pour a large coffee because the spacewalks are 6 hours or so in length. So perhaps a coffee pot, not just a glass. But yes, you're right. It's the Crew 3 Dragon. Sorry, I didn't quite get your reference there for a moment. But yes, Crew 3 Dragon is on the station. And starting next week, we're going to add a little bit of spice to our evening broadcasts. We're going to start reviewing 2021. What were the highlights? I guess we should also include the lowlights, but the highlights in particular of astronomy and space exploration for the year 2021. So keep an ear open for next week's broadcast, where the on-deck team will presumably each put forward their favorite moment from 2021. So, news. Okay, we've got 3 items that we want to deal with here, and Mars seems to be slightly topical tonight. Sana, would you like to take us back to the planet number 4?
Sure. So I have a couple pieces of news about Mars. So to start off, there's some interesting new results out of NASA's InSight lander. InSight is just unlike Curiosity, InSight is just a stationary lander that touched down on Mars near its equator in the Elysium Planeta in 2018. The main thing that the InSight lander wanted to accomplish was to use Mars quakes to study the Martian interior. So far, it's given scientists a pretty rough idea of what the inside of Mars looks like. It's studied information about Mars's core and its mantle and its crust, but it hasn't actually generated a full map of what Mars looks like under the surface. That is until now, because data from InSight has now given scientists their first look into the Martian interior. It did this by using a really new, interesting technique that listens to how wind makes the Martian crust vibrate. It was a team of Swiss scientists who used this technique. It was originally developed to study the Earth's interior and to determine what places on the Earth were at risk of earthquakes. So the way that it works is that there's a lot of stuff on a planet, like wind, or in the case of Earth, the ocean, that can produce these really small vibrations on the surface. They're very, very small vibrations, nothing that you would ever be able to detect without sensitive instruments. And these vibrations can propagate very deep into the surface. So if you have an instrument that's sensitive enough, like the InSight lander, you can detect these vibrations deep under the surface and then use them to study the interior of the planet. So that's what they did with the InSight lander. It's a pretty hard thing to do on Mars, much harder than it is on the Earth, because Mars doesn't have oceans to produce vibrations, and also the atmosphere on Mars is a lot thinner, so it produces much weaker wind than it does on Earth. But the team of scientists were still able to use data from InSight to get a pretty detailed map of the Martian interior down to a depth of about 200 meters. So this is basically what they found. Right below the surface, there's a layer that's 15 meters thick of sandy regolith. Then under that, there's a 15-meter thick deposit of solidified lava that's estimated to be about 1.7 billion years old. Further underneath that, there's a deep sediment at a depth of 30 to 70 meters, followed by another thick deposit of solidified lava that should be about 3.6 billion years old. And that was as far down as they were able to get with this data. So some scientists think they understand where some of this came from. They think that the sandy regolith layer just under the surface probably came from a meteorite impact, which ejected material off of the surface, and then it rained back down into where it is today. But they are pretty surprised by the existence of this sedimentary layer. They were not expecting to find that, and they really don't know where it came from yet. So this is still an open mystery that will hopefully be solved in the future. However, what they do say that these that these results indicate that Mars has a much more complicated geological history than what we expected. So it looks like there's probably the geological history of Mars is going to be revised because of a lot of these findings. So it sounds like the team does want to continue doing this work to try and push further down into the surface of Mars using the same technique that they used. So it seems like a really interesting technique, and I hope they are successful because it would be really cool to learn about the Martian interior. So that was it from the InSight rover, but while I'm talking about Mars, there's some more good news from the Ingenuity helicopter. It's now completed its 16th flight on Mars. That was on November 21st. It flew 116 meters for 109 seconds. At this point, I think it's flown pretty far from its original landing site, but it's now on its way back to its original landing site so it can start a new excursion to an area called the Three Forks, which is a funny name. I tried looking it up, but I couldn't find where that name came from. But I think Perseverance is going over there and it's going to follow Perseverance on its journey. But one thing that's interesting about this, or maybe a little bit sad, is that it is getting a lot harder for Ingenuity to fly right now because the Martian atmosphere is thinning with the season changes. So it has to use a higher spin rate to fly. And I don't know how much longer it's going to be able to keep flying, but hopefully for a while.
It's also getting colder, and that means the batteries on board Ingenuity have to work a little bit harder, and that's always a bit of the Achilles heel for vehicles on Mars when you're having to spend so much energy just keeping yourself warm at night. It eventually means that your batteries don't charge up as well during the day. But nonetheless, Ingenuity has been incredibly successful. It was meant to fly 5 times in the month of April and then call it quits. Well, I think you said this was the 16th flight, yep. Sana. So it's flown 3 times more often, and it's flown much, much further. It's doing some really neat science because it is able to take stereoscopic images during its flight because of its vantage point, and that's allowing the Perseverance team to get a bit of a head start on, gee, that rock looks interesting, before they actually have to sort of drive Perseverance over there. So it's doing very, very well. And so too is InSight. I mean, InSight has been there now, I think, 4 years. So it's doing very well in terms of listening to the interior, probing the interior. One of its instruments, the mole, wasn't very successful, but the seismograph and the ability for InSight to monitor the very gentle variation in planetary position as it orbits around the sun is giving further insight into the planetary interior. So I think everybody is quite satisfied with InSight despite the loss of the heat transfer experiment, which was the mole. So, Palvisha, I believe you want to give us an update on the James Webb Telescope. And, Sana, please make sure you've got a box of Kleenex handy.
Okay.
Well, that's right. So, 5 days ago, I believe it was, NASA announced that the launch for the James Webb Space Telescope is once again going to be delayed by 4 days. It was initially supposed to launch on December 18th of this year, and the launch date has now been moved to December 22nd. This is not the first time it has been delayed. This telescope was supposed to launch in 2007, and since then it has undergone numerous delays, with launch dates being extended multiple times. This latest extension comes as a result of an incident during launch preparations, where a clamp band that was securing the observatory to the launch vehicle adapter unexpectedly detached and caused the entire telescope to vibrate. Further announcements are going to be made once additional testing is completed this week to confirm whether the vibrations did or did not cause any damage. When it is launched, however, the James Webb Space Telescope will be the successor to the Hubble Space Telescope that has been in operation now for almost 31 years, but has also recently been undergoing operational failures. The most recent of these failures was in October of this year when the telescope experienced a multiple system failure that resulted in it being put into safe mode in late October. This is not the only failure this year. There was another failure prior this year in July, in which the telescope was completely shut down following a payload flaw in June. The James Webb Space Telescope launch, assuming it will launch this year, will come at the right time, considering Hubble, with all of its failures now, is approaching its end. However, However, if anything does go wrong during its launch, or during the 29 days of terror, which is the time it takes it to get to L2, the telescope will be unusable. So I think all I want for Christmas this year is for Webb to launch successfully.
Oh, I like that. Yes. Quite true.
This actually also leads me to a birthday shout out. November 20th, 1889, Edwin Hubble was born, and the Hubble telescope is named after him. He was born in Marshfield, Missouri, and had greatly influenced our knowledge of galaxies and our place in the universe. He basically determined that the Andromeda Nebula was not, in fact, a nebula, but was the Andromeda Galaxy, and using Cepheid variable stars within the Andromeda Galaxy, and had also proposed the Hubble tuning fork, which is used for galaxy classifications to this day.
Nothing to do with the three forks that Sana was looking for on Mars, no. Yes, James Webb has been a long, long road, shall we say. 2007 and $1 billion, and here we are in 2021 and $10 billion. That sort of sums it up in a nutshell. But there is no question in the world that if we are successful in deploying the James Webb Telescope, sorry, Sana, then we will have a wonderful instrument. It's a 6-meter diameter telescope optimized for infrared observations. It will be able to peer deep back in time to the formation of galaxies at the beginning of the universe. It can cut through the dust of the galaxies and allow us to peer at distant stars and their exoplanets. This is really a remarkable telescope, and Canada is one of the 3 principal agents that have put it together. While there will be obviously observers from around the world who will get time on James Webb, Canada has, I think it's 5% guaranteed time, Sana? Does that number sound about right?
Yeah, it's about 5%.
So mightn't sound a lot, but I'll tell you what, 5% is going to keep a lot of Canadians very, very happy, including Sana and her supervisor.
Yes.
Your 29 days of terror, interesting turn of phrase there, Palvisha. I think there's about 150 individual deployment mechanisms which have to operate successfully after launch to deploy the telescope. I mean, it's folded up inside the nose cone of the Ariane rocket, and it's got to unfold itself like a contortionist on its way out to Lagrange point 2. So, yeah, Sana, we're going to check your nails sort of on a daily basis through January.
Yeah, it's like if I'm really excited for this, and I'm going to be going a little crazy during the 29 days of terror. But if I feel like that, I can't imagine how some other people feel, because there's probably people who've been working on this for like 20 years. So I can't imagine how they would be feeling waiting to see if it was successful.
It's quite correct. It's quite correct. I'm just going to give a quick little shout out to the DART mission, which launched successfully last Wednesday. This is the double asteroid redirection test. For the listeners out there, be advised that the Didymos system that DART is aimed at is not, repeat, not going to destroy Earth next year, regardless of DART. It won't get within 11 million kilometers. It is a near-Earth asteroid, but this is not an asteroid which we need worry about for the next 100 years at least. But DART, nonetheless, is planning to impact one of the 2 components of this double asteroid. Dimorphos is the name of the satellite that is orbiting around Didymos, and it's going to slam into it at about 6.5 kilometers a second, and hopefully change the orbital period of Didymos by literally just a fraction of a second, but of course, us astronomers, we're very good at measuring really small deviations. We expect to be able to detect the change in orbital period with time that DART has created. Meaning, of course, that the kinetic impact, we know how much energy we're about to slam into this system. Will that be enough to change the trajectory of a celestial object? And if it is, it will be proof positive that we can, in fact, redirect potential hazardous objects as they come towards the Earth if we know about them in enough time. At any rate, stay tuned for DART's impact. It's not until October of next year, but it's a really neat